For a very long time, the deep ocean was treated like a biological afterthought. A dark place, a cold place, a crushing place, a place where life might survive, but only in thin, scattered forms. A place too poor in energy, too short on oxygen, too intense in pressure, and too removed from sunlight to host anything but sparse, slow, and simple existence. That picture felt logical, and it was wrong. Because the deeper scientists explored, the more the deep ocean kept exposing the same failure in human imagination. We confused darkness with emptiness. NOAA says more than 90% of the ocean is deep ocean, yet explorers have visually seen less than 0.01% of the deep seafloor, and scientists estimate that roughly 2/3 of marine species may still be undiscovered or undescribed. That means the largest habitat on Earth is also one of the least understood, and what researchers have found there has forced a complete rewrite of the old story. The deep ocean is not biologically marginal. It is not geologically still. It is not ecologically simple. And it is not disconnected from the rest of the planet. Instead, it is a realm of glowing predators, drifting scavengers, chemically powered ecosystems, strange symbioses, and life forms so specialized that they make surface biology look almost conservative by comparison. Monterey Bay Aquarium notes that the majority of midwater species and nearly half of all seafloor species in the deep sea produce their own light. Smithsonian points out that even the demonic-looking vampire squid is not a bloodthirsty hunter, but a deep-sea drifter, feeding on marine snow in low-oxygen darkness. That is what makes the deep ocean so fascinating now. We were not just wrong about a few animals. We were wrong about the nature of the place itself. The first big mistake: we thought sunlight was non-negotiable. One of the deepest scientific assumptions humans carried into ocean science was this: life might persist without sunlight, but it could never truly thrive without it. That idea made perfect sense from the surface. On land and in shallow seas, sunlight powers photosynthesis, and photosynthesis powers most familiar food webs. Remove the light, and it seemed reasonable to assume that the biological world would thin out into a weak shadow of itself. The deep sea would still have life, yes, but only because scraps from above drifted down to keep a few tough creatures alive. That view collapsed when scientists found ecosystems that were not merely surviving in darkness, but built around it. Hydrothermal vent systems changed everything. Woods Hole. Oceanographic Institution explains that hydrothermal vents form where seawater circulates through hot, geologically active crust and returns enriched with chemicals and heat. Around those vents, entire ecosystems develop that depend not on sunlight but on chemosynthesis, biological processes driven by chemical energy. That was not a minor discovery. It meant that the deep sea had revealed an alternative foundation for life. Not life clinging to the leftovers of the sun, but life structured around Earth's internal heat and chemistry. Once that happened, the deep ocean stopped looking like the exhausted tail end of surface ecology and started looking like a separate biological logic. Hydrothermal vents showed that darkness is not the end of food webs. Sometimes it is the beginning of a completely different kind. That single realization reached beyond Earth immediately. If life could organize itself around chemistry instead of light in the deep ocean, then buried oceans on icy moons no longer seemed like fantasy habitats. The deep sea became not just an oceanographic frontier, but a model for where else life might exist in the universe. So the first major thing we got wrong about what lives in the deep ocean was not just underestimating abundance, it was underestimating possibility. The second big mistake: we thought the deep sea was sparse. Even after researchers accepted that some deep-sea ecosystems were more active than expected, there remained another assumption. Whatever life existed, there must still be thinly distributed and ecologically simple. That assumption also turned out to be wrong. The deep sea includes a huge variety of environments: open midwater, seamounts, abyssal plains, submarine canyons, trenches, whale falls, cold seeps, hydrothermal vents, and undersea mountains. Each creates its own combination of food availability, fluid chemistry, current patterns, substrate type, and pressure regime. Scientific syntheses of deep ocean ecosystems describe the deep sea as the largest biome on Earth, with characteristics so distinct that it cannot be treated as one uniform environment. And the organisms living there are not generic placeholders, they are specialists. Monterey Bay Aquarium notes that the majority of midwater species and almost half of deep seafloor species generate their own light. That means deep sea life is not simply sparse and passive. It is visually active, communicative, deceptive, and behaviorally complex in ways that our surface intuitions tend to miss. Different species use bioluminescence to attract mates, lure prey, evade predators, and communicate. This matters because it completely changes the emotional texture of the deep sea. It is not a mostly empty black void with occasional life drifting through it. In many places, it is a crowded arena of signals and survival strategies happening beyond the range of human senses. The darkness did not eliminate visual ecology. It transformed it, and once you understand that, the deep sea stops seeming quiet in the biological sense. It becomes busy. Just busy in a language we are not equipped to see naturally. The third big mistake. We thought deep sea animals were just weird surface animals. This is one of the easiest misconceptions to make and one of the hardest to unlearn. People often assume that deep sea creatures are just exaggerated versions of familiar species, a little bigger-eyed, a little more transparent, a little uglier maybe. But the deeper researchers looked, the more obvious it became that many deep-sea animals are not simply modified surface species. They are creatures built around completely different energetic, visual, and ecological rules. Take the vampire squid. Its name and appearance suggest a predator from a horror story. But Smithsonian explains that despite its demonic look, it is not a blood-drinking terror at all. It survives in dark, low-oxygen waters with relatively few predators and feeds on drifting particles called marine snow using two long, sticky filaments. That is a perfect example of how wrong our instincts were. We expected deep-sea life to be monstrous in the obvious way, more violent, more aggressive, more visibly predatory. Instead, some of the strangest-looking creatures in the deep are not apex hunters at all. They are exquisitely specialized scavengers living slowly in environments where energy must be stretched and wasted motion can be fatal. In other words, the deep ocean does not just make animals look strange. It reorganizes the very meaning of survival. The fourth big mistake: we thought pressure would limit complexity. Pressure was long treated as one of the ultimate biological barriers. As depth increases, hydrostatic pressure rises dramatically, and for surface organisms, that pressure is indeed devastating. It distorts proteins, alters membranes, and breaks the assumptions under which most terrestrial physiology works. So the old conclusion seemed obvious. The deeper you go, the less complex, less diverse, and less active life should become. But deep-sea biology has shown that pressure does not simply suppress life, it selects for different versions of it.
Kept drifting downward. The vents, the giant worms, the crustaceans, all of it felt connected. This wasn't random growth. It was a system. Energy flowed from the Earth itself into living forms, shaping bodies and behavior over millions of years. As we prepared to ascend, Alara reviewed her samples one last time. "This goes beyond gigantism," she said. "This is a full network of life shaped by extreme conditions. Every large body, every slow movement is part of a long-term strategy." She paused, then added, "And whatever we saw down there, That's something we're not ready to explain yet. The steady hum of the submersible filled the silence as we rose. I realized the giants weren't strange exceptions. They were the logical result of their environment. The deep sea didn't reward speed or strength alone. It rewarded patience, efficiency, and balance. As surface light slowly returned, I felt both uneasy and motivated. We had seen how gigantism was supported, how the ecosystem worked, and how much still remained hidden. The ocean had given us answers, but also bigger questions. Somewhere below, the abyss continued on, quiet and immense, waiting for us to return. Titans awaken! The trench felt different that day. Even before we descended, there was a sense of tension in the air, as if the ocean was aware of us. The Nautilus II slipped into the darkness, its lights cutting narrow paths through the black water. I focused on the instruments and sonar, but my attention kept drifting downward, toward what waited below. Small points of light appeared first. Bioluminescent flashes moved past us in short bursts, blinking in patterns rather than at random. Alara leaned closer to the screens. "They're signaling," she said quietly. "That's how species communicate down here. Light replaces sound." She pointed to a faint trail of moving light below us. "Something large is responding." Then we saw it. At first, it was only a shadow, wide and stretching beyond our lights. Slowly, the shape became clearer. Long tentacles unfolded, moving with control and purpose. The body followed, massive and solid, built for strength and long travel. Faint blue and green lights pulsed across its mantle, flashing in steady rhythms. It was a squid, but far larger than any known species. Alara spoke carefully, almost in disbelief. "This is it," she said, "a deep sea giant. Its size allows it to hunt large prey, defend itself, and move efficiently through the trench." She pointed to the sonar data. "Its muscles are thick, and its blood chemistry allows it to stay active in low oxygen. Even its reproduction is designed for long life and survival. Nothing here is wasted." I watched as one tentacle stretched toward a group of large crustaceans, then slowly pulled back. The movement was calm, controlled, and effortless. One limb alone was longer than our submersible. The scale was hard to process. Then the squid reacted to us. Its light patterns changed, flashing red and purple. A tentacle brushed the hull, not aggressively, but with curiosity. The submersible shook slightly. My chest tightened as I realized how fragile we were compared to it. Alara's hands tightened on the controls. "We need space," she said. "Slow retreat." We moved back carefully as the squid passed through the trench. It didn't chase us, but the water around it shifted with every movement. One mistake could have pushed us into the trench wall. Fear and awe mixed in my chest as I watched it move with total control. Alara continued to speak, steady and focused. "Its size supports ambush hunting, long reach, strong muscles, slow metabolism. It can stay down here for hours without rest. Survival here depends on patience and timing, not speed." Suddenly, the squid pulled away fast, sending sediment and light flashing through the water. We had drifted too close to its feeding area. Alara guided the submersible out with precision, and after several tense moments, the water settled again. At a safe distance, we watched the squid fade back into the darkness. Its lights pulsed slowly, then disappeared. Alara spoke softly. "We can study it, but we'll never fully understand it. This species belongs to a world we can't survive in." As we began our ascent, I felt changed. We had seen the peak of deep-sea gigantism, not as a monster, but as a master of its environment. The abyss had shown us how life adapts when pushed to the extreme, and it reminded me that exploration is not about control, it is about respect. Return to the surface. The ascent felt slower than expected. After spending so much time in the abyss, it was hard to leave it behind. The submersible rose steadily, and faint light from above slowly returned. When we finally reached the surface, the horizon looked calm and ordinary, almost fragile compared to the powerful world we had just left below. Alara rested against the console for a moment before speaking. Her voice was quiet but certain. "Deep-sea gigantism doesn't happen by chance," she said. "Cold temperatures slow metabolism. High pressure supports dense, strong bodies. Oxygen may be limited, but these animals use it very efficiently. Food is scarce, so slow growth and energy savings are rewarded. Living longer allows them to reproduce over time, and large size helps them avoid predators and hunt bigger prey." She paused. "Every condition works together. These creatures are built for a place humans can only visit briefly." I watched as she organized the final data, DNA samples, images, and video recordings of the Leviathan, the giant crabs, and the vent ecosystems. Her usual focus was still there, but now it carried something more: respect. She looked up at the early morning light reflecting through the window. "What we've seen is only a small part," she added. "The ocean holds countless life strategies. We're just beginning to understand them." That realization stayed with me. I felt small, but not in a bad way. Humans often think of themselves as masters of the planet, yet the deep sea showed a different truth. Survival isn't about control or power. It's about adapting slowly, making small improvements over long periods of time. The giants of the deep weren't accidents. They were the result of patience, balance, and time. As the submersible floated on the surface, I thought about everything we had seen. Each shadow in the trench had taught us something important. Curiosity without respect can be dangerous. Observation without humility is incomplete. True understanding comes slowly, in pieces, not all at once. We had looked into a world that did not need us, yet allowed us a brief glimpse. Then, just before the night fully gave way to morning, I noticed something beneath the waves. A large, distant shadow moved far below the surface. It was even bigger than the Leviathan, impossible to identify. It vanished almost instantly. Alara noticed my reaction and nodded quietly. No explanation was needed. The ocean was reminding us that there was still much we didn't know. I breathed in the fresh air. It felt normal, familiar, but heavier somehow. The deep sea had changed how I saw the world. Its giants showed us that life can thrive under extreme conditions, not through force, but through efficiency and adaptation. As we returned to our everyday world, I knew part of me would always remain in the abyss, shaped by what we had witnessed. The ocean had shared a secret, but not the whole story. If you enjoyed this journey into the deep sea, please like this video, share it with someone who loves ocean mysteries, subscribe for more incredible wildlife stories. Now, question for you. Do you believe there are even larger creatures still hidden in the deep ocean? Let us know your thoughts in the comments below.